terminology and notation. Because, as you noticed outside, right, we kind of struggle when we're just talking about the numbers. We need some language to be able to say what's going on here, right? And the three most important pieces of language are these three words, okay? So, here's our first thing, displacement. Displacement. Now, displacement tells you about where something is. It's a position word, okay? But displacement is better than position because, for instance, suppose you set out to try and describe where is the ball at any given time when it's in the air. How would you describe it? Well, at the moment, like, because we live in a 3D world, it's in 3D space. So you'd have to provide a set of coordinates for it, but because we're in 3D space, there'd be an X coordinate and a Y coordinate and a Z coordinate, and that's really difficult. Not to mention the fact that we're only interested in one of them, right? Because even though we live in three-dimensional space, it's only moving in one-dimensional space, okay? So therefore, you should say displacement is about position. We use an X to denote that, okay? X being our variable of choice. It can get a bit confusing when you're talking about things that move up and down, right? Because when we graph this, you're going to graph X, and which axis will you use? You'll use the vertical axis, right? We're not used to putting X on the vertical axis. We're used to putting Y there, and that is, believe it or not, a big source of confusion. But we use it as X because, well, Y is the next letter. It's a bit weird having a Y with no X, so that's why we just start with X. Okay. Now, our next idea after that, and you referred to this outside, is velocity, okay? Now, connected to velocity is the idea of speed. And they are not the same, and we really need to understand the difference. Okay? How would you explain these? Speed and velocity. Speed and velocity. What I like to think about is, picture, how many of you are learning to drive? How many of you are learning to drive? Yeah, most of you. Good. Okay. So when you look at the speedometer, right? You look at the dial there, and you've got all of these numbers around, and then you have, this thing here, which is just pointing there when you're not moving. Okay. It's at 0, and then you hold down the pedal, and it moves up, and then you read off your speed based on whatever number it's pointing at, right? Now, tell me, what happens when you shift into reverse and you press the pedal down? What happens to this? It does exactly the same thing that it does if you weren't in reverse, right? Namely, it goes up to 60. If you're a maniac, do we reverse at 60? Okay. Just warn me so I get out of the way, okay? This is a speedometer. It only tells you how fast you're going, right? How fast you're going. Let me put this in another color. Speedometer, speed, is about how fast you are moving. And it doesn't care which way that direction, which way that speed is going, okay? It'll be 0 to 60, forwards, or 0 to 60 backwards, or whatever, okay? Our velocity is different. Velocity is the same idea as speed, that it's about, how fast something is going, but it takes something additional into consideration, namely direction. So the way I call velocity is, I call it speed with direction. Now remember, we are only moving in one dimension, right? And that might be up, down, or left, right, or forwards, backwards, right? But that's why, because you're only moving in one direction, there are only two choices for this, right? You're either going one way or the other, and so those correspond to positive and negative, okay? So this direction here, right? That's positive or negative, okay? Now, in some ways, because we're making up, all of this language and how to describe this thing, right? We can make positive and negative whatever we like. But some things tend to make more sense than others. For instance, it makes sense to call up positive, right? Because we're used to thinking of, that way equals positive and down is negative, okay? So as a convention, you will see positive means up and negative means down. How about left, right? For you guys, left, right. Which makes more sense to be positive and negative? So we usually think of a Cartesian plane, right? And negatives off this way and positives off this way, right? So therefore, this will be positive is right and negative is left, okay? Now, it doesn't have to be that way. These are conventions, okay? But if the situation suits us, for instance, if I'm not thinking about someone throwing a ball up and down, maybe I want to think about, for instance, someone dropping a ball off a cliff, and I want to think about that distance. Maybe I will reverse this. I can do it however I like, so long as I define it, okay? Okay, velocity and speed. You also need to think about, like, how do we measure these things, okay? This speedometer, right? What's it telling us at any given time? Well, in theory, it's telling you what speed you're doing at that moment. You look at it and it says 55. So you're like, right now I'm moving at 55 kilometers per hour, right? But if you take your foot off the pedal, then it changes, doesn't it, okay? So what you're talking about there is what we call, and this is a separate category over here, it's either instantaneous, as in an instant of time, that's the speed you've got, or what would be the opposite? Rather than just looking at one moment, right, you would think about it of a whole bunch of moments, over, say, a whole journey, right? So, for instance, it took me, about 12 minutes to get to school, and I know that it's about, I think it's about 6 kilometers, okay? So you could say that amount of distance over time, and that wouldn't give you an instantaneous speed or velocity, would it? What would it give you? An average. Good. Okay. So you can have average speed and average velocity. You can have instantaneous speed and instantaneous velocity, right? So these categories overlap. Is there anything else I wanted to say about that? Yeah, sure. Okay. One last thing before we move on to the next subpoint. Velocity, right? When I release the ball, okay, and it went upwards, okay, what does that mean about the velocity? It's positive, right? Now it starts to come back down. It's negative by the time it ends, right? So therefore, I can think about, when I'm working out average speed, I told you it was, I drove 6 kilometers, okay, and it took me that amount of time, right? Well, suppose, like this ball, right, I drove, and I ended up where I started. What's the total displacement? How far away I am? I'm zero distance from where I started, okay? So in that case, even though I might be driving for a while, or I might be throwing the ball pretty hard, okay, the average speed would be, or whatever you calculate, okay? But the average velocity, well, because I haven't gone anywhere really, right, over the whole journey, so therefore the average velocity would be 0. That's funny. Does it make sense though? Think about it. We'll come back to that idea. One last thing, going off here, acceleration. Oh, no, I was naughty. I forgot something. We call this x, right? We call this x. So therefore, it stands to reason that if you're thinking about velocity, right, which is how displacement is changing over time, what would you call that? How would you denote it? dx on ut. Good. So your rates of change idea and thinking about how derivatives relate to quantities is going to serve you really well here. Okay. We called speed and velocity, right? About how fast this thing is changing. Okay. Well, acceleration does exactly the same thing, but it does it for speed, right? Or speed and velocity. Okay. So acceleration is about how fast, or if you like, at what rate. It's just that how fast is kind of how we talk. At what rate, how fast is velocity changing? Now, I've got to warn you right now, acceleration is the hardest part of motion to understand. All kinds of motion. Okay, well, I rubbed off the rest, right? Acceleration can be very counterintuitive. Okay, we're going to unpack it as we go through. It'll be easier with examples. I just want to give you one quick warning. Never ever write the word or use the word decelerate or deceleration. Decelerate. Okay. We talk about decelerating and deceleration. I guess if you had to choose a synonym for this, what would you say? Slowing down. Good, that makes sense. Okay. Why is it such a bad idea to use that word? I'll tell you why. When you talk about slowing down, right? Slowing down is a speed word. It's not a velocity word. Okay? It's about this. right? It's about 0 to 60 and how that's changing, okay? But acceleration is really something about velocity. We want to take direction into account, okay? And deceleration doesn't do it. It just tells you, you know, you're slowing down or you're speeding up or that kind of thing, and it doesn't tell you which direction you're going, okay? So please put big red writing around it and make sure you don't do that. Last bit of notation. If velocity is the change of displacement over time, dx and dt. Okay. But if I want to know how dx on dt is changing, I differentiate again, don't I? dt squared x on dt squared. Okay. Now, you can always trust people from other fields of study to muck things up for you. So this all looks mathematically beautiful, right? But it's not just mathematicians who are interested in displacement, velocity, and acceleration. You get all kinds of people who are interested in it, right? And when you've got new kinds of people who are interested in something, you get new ways of writing things, okay? So thankfully for you, everyone pretty much agrees that we should call this x, okay? But there are certain types of people who will remain unnamed, who rather than saying dx on dt, they're like, what's all this d business? I don't need to worry about that. What's differentiation? I don't care. Just give me formulas so I can work with them. They call it x dot, not x dash, even though that's what you're doing. Okay? But it's how x is changing with respect to time. Okay? X dot, that's the way I read it. By the same token, they talk about acceleration not as d squared on, because I don't want to worry about the process by which I get to there. They call it x double dot. Okay? Which kind of looks like this looks like a bad emoticon, doesn't it? Anyway, okay, so x, dx on dt, d squared x on dt squared. I think that's your safest bet unless they introduce notation to you. This should be your default, okay? But you need to recognize, get this guy's face off the board, when they talk about x dot and x double dot, these are what they mean, okay? They're talking about velocity and acceleration, okay?